Hey, welcome back. It seems I have some unfinished business here. Why? Yes, after the last video, some have asked questions. If you save cost in my use of Apache Superset in visualization, and then save costs in my ETL using Python and SQL. Now, how will you save cost in terms of the pipeline orchestration or scheduling, as the case may be? Yes, they are right. In terms of visualization, instead of paying for those expensive licenses or for those Silicon Valley platform for analytics, we were able to use Superset. Simple. Then for the ETL, yes, we use Python and combine with SQL and created a package, and that package is reusable. Fine. Now, in terms of the orchestration, the pipeline orchestration, there are bigger tools everywhere, from the Azures of this world, the GCPs of this world, and those airflows and stuff like that. But if you want to save costs, if you don't have money to pay those licenses, a startup, for instance, or you want to minimize cost, even though you're an enterprise, then what I did, I use cron jobs. Most of us are familiar with cron jobs. If you check, there is a folder here where I store those cron jobs. But in real client situations, I use their Unix box or Linux box. So I will create those cron jobs. For example, when you see here, you will see the cron jobs here. You see the first one here. You have the cron jobs that is calling the Python file that I created in my last video. And then you can see these cron jobs here. Let me open it. You can see it here. That's the cron jobs. Now you will see where the Python file is called. That Python file that calls those packages that does the modeling and transform the data into a star schema. So this shell file will call that particular Python file. Now, in terms of the actual scheduling, I also have another shell file here, which is the daemon shell file. You can see the daemon shell file here. Now, let me show you what is right there. You see where the scheduling is done. Now, in this daemon shell file, you see I will in turn call the earlier shell file, which is the run extractor shell file. Then thereafter, the intervals will now be indicated here, whether it's going to be daily, then or maybe it's 1 hour, it's going to be hourly, as the case may be. Everything is done. So with this, your program, the ETL to visualization is complete, in the sense that the pipeline is now being orchestrated with this job. But again, you can also make it more flexible. If you don't want to use cron jobs, you can actually use the system D feature in Linux. For instance, I think in those Linux boards there's a folder called etc/system/d/system, something like that. Then you create your system D file right there. So there's I think you can, if you want to call it a name, maybe data schedule dot, it's always dot system, dot system. Then you create the file. Then at the end of the day, you just enable the system file, and then you start it, and it runs according to the interval that is specified, and your data is streaming from the source for visualization. So, but if again the user insists on using the bigger tools, yes, we can also do it for him. For instance, if you are interested in airflow, that's maybe in GCP, for instance, this is the environment. You can see where it is scheduled, the time to run, the last time it was run, the maximum duration, everything is scheduled, and you have the monitoring at the end of the day. But if you want to save costs, then I give you the cron jobs or the system D, as the case may be. So that's how we save costs, in 3 ways: from your ETL to visualization using Superset, then the pipeline orchestration using cron jobs, as the case may be. Thank you very much. Thank you.